Hello there! This video is the first part in a short series aimed at giving people who want to use C++, the Unreal Engine, a helping hand. If you are a blueprint-only Unreal developer who wants to get into C++, or someone with prior C++ experience who wants to apply it to Unreal, then this is for you. In this part, I'll briefly skip over some of the bits of installing the software you will need and setting up your development machine to allow you to work with C++ in Unreal. And then I discuss the most common classes and features that you may encounter while working on your projects. I'll cover some basic things about how Unreal C++ projects work to help people from a blueprint background, and I talk about some of the pitfalls that people who already have C++ experience might encounter, so that hopefully you can avoid them. The majority of this video is just to provide you with useful background information. You don't need to do anything or follow along with your own project. It's all just intended as useful foundation knowledge that will help you out later. Practical examples of some of the things covered here are in the next video. So yeah, you can just kick back and take it easy with this one. One of the first things people would probably address is the kind of hardware specifications you're going to need on your machine. But I'm not really going to do that, because these things frequently change and any information I give you will quickly be out of date. Instead, I will leave a link to the recommended specifications page of the Unreal documentation in the description of this video. Having a fancy Dan CPU with more cores than your aging dog years might help you compile your code faster, but that's not essential either. Having lots of RAM is usually a pretty good idea, as is having a sizable amount of hard drive space, because just installing various engine features will probably take up over 90 gigabytes, and that's even before you start creating your own projects and bloating them out with every free asset you can lay your grubby little hands on. I'm going to concentrate on a Windows development setup here, because that's what I'm using and the majority of people who are interested in the subject seem to be using it also. However, you can develop using macOS or Linux, and you can find details for those platforms on Epic's Unreal Engine docs website. I'm going to assume that most of you will already have the Unreal Engine installed on your development machine, but in case you don't, to begin with, you're going to need to install the Epic Games Launcher, which we'll use to install the engine. And to use that, you're going to need an Epic Games account. So follow this download link, which is also in the video description, and click the Download Launcher button if you don't already have it, or the Open Launcher button if you do. When you choose to install the Unreal Engine, you will generally be prompted to install the most recent version. However, if you want to install a previous version, this is also an option. You might wish to do this if you know that the hardware or operating system specs you wish to work with don't quite meet the criteria for the current version. In addition to the core components, which are mandatory, you can choose to install some other things. My recommendations for those with C++ development include the starter content, the templates and feature packs, which is fairly big, the engine source code, and editor symbols for debugging, which is a nice to have, and it's pretty big, at over 60 gigabytes. An integrated development environment, or IDE, is where you will edit your code and do a bunch of other generally programmery type things, so you're going to need one. Visual Studio is almost the de facto IDE for development on Windows platforms. It seems to have been around forever, and the good news is that Microsoft are letting you have a very competent version of it completely for free. It's certainly got enough features to let you code Unreal games. Epic have a really good page detailing not only how to download and install Visual Studio, but also some configuration options and tips to help get you going. So I'm not going to fight that. Let's work through the page together. As usual, there's a link in the video description to take you right there. Just so you know which version you need, if you're using the Unreal Engine version 4.25 up to 5.0, you will need Visual Studio 2019. Unreal Engine 5.1 and above can choose to use either Visual Studio 2019 or Visual Studio 2020. When you install Visual Studio, you need to bear in mind that you need a few things from the install to be able to work with your Unreal Engine projects. Those things are called workloads by the VS installer. The workloads you will need are the .NET development environment, which includes C#, desktop development with C++, universal Windows platform development, and game development with C++. In addition to these workloads, you also want to include the following tools: C++ profiling tools, C++ address sanitizer, and Windows 10 SDK, and the Unreal Engine installer. The good news here, though, is that if you forget to install these things or don't get this setup quite right, the chances are, although your project won't work properly in Visual Studio will now give you a message telling you that there's a problem and prompting you to download the specific things you're missing, which is quite nice. If you've watched any of my other videos, you might be aware that my IDE of choice for Unreal development is Rider, produced by a company called JetBrains. Without any hesitation, I can say it's simply light years ahead of anything you can set up with Visual Studio and even paid plugins like Visual Assist. The downside, of course, is that it is a paid product, but in my opinion, well worth the price. If you want to check it out, I put a link in the description to a 30-day free trial. You can open your project in Rider and then go straight back to Visual Studio. It's not going to screw anything up for you, so you can just go back to using Visual Studio after your 30-day trial expires if you want to, but I don't think you will want to. I think Rider provides more features which actually help you learn C++ for Unreal Engine. This is, of course, all just my own personal opinion. I'm not sponsored or anything. Well, obviously not until thousands of you aspiring game devs have all subscribed to this channel, at which point I can happily abandon all my principles and shill for any old rubbish that comes my way. That's right, I'll be here wearing their branded merch while poisoning my internal organs with dubious energy drinks and telling you all to buy a Scottish Lord title and shell out for some dodgy VPN. And if all that goes well, I have an amazing NFT project I want to get you interested in. Oh yes, my friends, you really gotta have dreams. If you are already somewhat familiar with C++, you know about header and source files, .h and .cpp. The header files, .h, are where you define the things that you are going to have, for example, in a class. And the source files, .cpp, are where you actually have the code that does whatever you want it to do. Many newcomers to C++ ask why it is that way, and the short answer is it's for the compiler. The compiler can scan over all the header files first, and then it basically knows what's what before it digs into the meat of the actual code in the CPP files. Yes, that is a massive oversimplification there, but we don't want to get too bogged down with that kind of stuff here. What we do want to dwell on for a moment is how Epic generally structure their source code. Their standard is to use public and private folders. Generally speaking, all the .h header files that define things which should be visible only inside the code module it's written in are in a private folder, and anything that should be accessible from outside the module, such as things which will be used by other modules, should be in the public folder. The CPP files generally all go in the private folder regardless, because they're implementation, even if their .h header files are public. Now, this might sound a bit confusing, but you don't need to do any of this if you're just making a simple game and all your code is going to be in the default module for that game. There isn't anything outside of that module which will use that code, and so none of this matters to you. When it does become more important for you is when you progress to the point that you want to put code into separate modules or create your own code plugins, which I will discuss a little further on. You may have learned some C++ from your school or college, or perhaps you use it professionally in an environment where you have used it on your job, or have learned it independently as a hobbyist. If so, that's all great. That familiarity will certainly help you get to grips with the Unreal Engine. However, there are a few things to bear in mind and some false assumptions you might make that could confuse or trip you up. So let's briefly go over some of those things. Generally, when you learn C++, you are taught principles of object orientation. You're introduced to the idea of creating classes which act as a template from which you can create individual object instances. You are shown that you can create those instances with the C++ new keyword, and you can delete those instances when you don't need them anymore. You are taught the concept of constructors, functions which automatically run when instances of the class are created, so that that instance can set itself up, and destructors, which are functions that automatically run when the instance is destroyed, so that the class can shut itself down gracefully and clean up any memory and other things it may have been using. That's all good standard stuff, but because Unreal classes are basically managed by the engine, it's not exactly how we do things. We don't create instances of Unreal objects with the familiar C++ new method. We have to use engine features, such as create new object or spawn actor. And we don't delete our objects either. Generally speaking, you don't actually have to do anything to get rid of your object instances once you're done with them. Once Unreal detects that there is nothing holding on to a reference to that instance, a pointer, then it will mark the object for destruction. And when it decides to perform garbage collection, it will get rid of it for you. For other reasons, constructors and destructors on your Unreal classes may not perform as you expect. Generally, with Unreal classes, the constructor is for initializing a default instance of that class. This is referred to as a CDO, or class default object. It is an instance of the class which is used to clone copies from during play, and it runs when the code module the class is in is loaded, or when the engine starts, or maybe with live coding when you change stuff. This often confuses those familiar with C++, as they expect the constructor to run when they create each instance. But don't worry, you just need to get used to some small changes. The constructor is for setting initial property values and creating contained sub-objects that will apply to all the instances you make of that class. A function is provided called beginPlay, which you can override to do specific things at the moment each instance has been created and is ready to use. Similarly, you can use beginDestroy to do anything you may need when that instance is cleaned up. But remember that cleanup generally happens when the Unreal Engine feels like doing it, not necessarily at the moment you no longer use the instance. Another sticking point for people familiar with C++ outside Unreal is that Unreal doesn't use the standard C++ libraries. In one form or another, the Unreal Engine has been around quite a long time, beginning in 1995 in fact. As far as the C++ standard libraries go, Epic initially decided to bypass them completely. If there was a particular functional feature of the standard library they felt was required by the engine, they simply coded their own version themselves. In fact, in a post on forums.unrealengine.com from way back in 2015, Tim Sweeney himself said,
"The Unreal Engine's avoidance of the C++ standard library's containers is primarily historical. C++ was standardized in 1998, the same year we shipped the first Unreal Engine game. Back then, the standard libraries were controversial, poorly implemented, and very inconsistent between platforms. They made very aggressive use of new C++ features that hadn't yet been production proven and had some significant problems interoperating with C libraries."
And you can see why avoiding it might have given Epic some benefits. They could be sure of exactly what code was being used, how optimally it was coded, and have quite precise control over exactly which code would be used on the increasing number of platforms that the Unreal Engine supports. However, in their Unreal Engine coding standard document, Epic do state the standard libraries may have some things which are both useful and that they don't want to rewrite or wrap themselves, and as such there is nothing stopping you from using them. However, you need to realise that the majority of the Unreal Engine does not rely on them, and for many tasks you really need to use equivalent classes provided by the engine. I'll link that doc in the video description. Read the section Use of Standard Libraries for some guideline do's and don'ts regarding this. It's often first encountered with collection classes, with many C++ programmers immediately reaching for standard vector, for instance. Don't worry though, the Unreal Engine provides a slew of templated collection classes for pretty much any scenario, and you should really be using those instead of what you used to. Sorry about that. Let's take a quick look at some of the most often used ones. You might already be familiar with these if you're coming from a blueprint background. When you define variables in your blueprints, other than single instances, you can also choose one of the following three container types. T-array, a one-dimensional array of T. I have made a separate video talking about T-array and how you can easily implement multi-dimensional arrays based on it. See the video description for the link. It's basically the 1D array you know and love, but implemented for Unreal, meaning you can mark it with the UPROPERTY and the contents won't be automatically garbage collected out from under you. We'll get back to that in a little bit. T-map, storage of objects by key and value pair. As it's templated, both the key and value types are definable to whatever you need. T-set, storage of usually unique items, which are keyed by the stored object's hash value. There are also plenty of other really great templated collection classes provided by Unreal that you can use too. For a more exhaustive list, the Unreal documentation is, once again, your friend, and I'll stick another link in the description in case you want to know more. Another major difference to C++ coding with Unreal compared to vanilla C++ coding is the heavy use of macros. Macro use in general makes the code appear almost like an enhanced version of C++, even though technically it is normal, valid C++. Although if you really want to split hairs, that's not totally true, because there's all sorts of other magic going on behind the scenes with C# and the Unreal build tool and the Unreal header tool and other stuff. But really, who cares? If you want to think of it as Unreal C++, I'm not going to knock you. And if you want to think of it all as simply elfin magic, you go right ahead. Many of the reflection macros you will use resemble attributes in managed languages such as C#. These are macro invocations which are generally placed immediately before specific things, like Unreal classes have uClass, structs have uStruct, individual properties have uProperty, and even functions can have uFunction. Some are mandatory. For example, you can't have an Unreal class without a uClass reflection macro immediately before the class declaration and a generated body macro somewhere inside the class body. And when you create a new class using the Unreal Editor, or from an IDE like Rider which understands Unreal, the macro invocations are automatically inserted where they need to be, in the empty class structure which is made for you, so you don't need to worry too much about that. But properties and functions don't necessarily need those things, unless you want to make use of them for some reason. Marking a field in a class with a U property will ensure that Unreal knows not to garbage collect it while your property has a reference to it. Let me spell that one out because it's quite important. If you have an instance of some Unreal class and another class has a pointer to it, don't expect that pointer to stay valid unless you mark it as a U property, because if there are no other pointers to it with U property on them, Unreal will be perfectly within its rights to go ahead and delete the thing referred to by that pointer, because as far as it's concerned, no one's using it anymore. And because Unreal does its garbage collection when it feels the time is right, you might actually still be able to carry on using that pointer okay for a little while, and then not understand why your game crashes sometime later in a seemingly unrelated piece of code. UProperty can also be used to tell Unreal that you want this property exposed to blueprints, and that it is read-only or read-writable in blueprints. You can also include tooltip text and have things grouped together in categories and subcategories when they are displayed in property windows in the editor. And it's a similar story with functions. Using uFunction, you can reveal the function to blueprints, and even have it display a specific name to blueprints that might be different from the name in C++, or indicate that the function is pure, that is, doesn't change anything in the class, and so it won't get an execution pin when the node is used in blueprints. If it's a function that will only ever be used by other C++ code, then many times you don't need to decorate it with uFunction. Blueprints won't ever know about it or have direct access to it. Assets. Assets in the Unreal Engine are content which your game uses. These things are not part of the compiled game code. They may be imported into Unreal after being created in external applications like 3D modeling programs, music creation software, or graphical editing packages. Things like meshes, animations, sound effects, and textures. Other assets are created inside the editor, such as blueprints, which are also assets. Referencing assets from blueprints is generally pretty simple. Because blueprints themselves are assets and are created in the editor, Unreal is free to offer you drop-down lists filtered with the specific type of asset you're interested in, and you just pick it. Plus, if you decide to move an asset from one place to another in your content structure, there are tools which can be used to automatically fix up anything that was using that asset, so it knows that it now lives in another location. But C++ doesn't work that way. You can reference assets directly in C++, and when you are new to coding C++ for Unreal, that's generally the first thing you try to do. With the content browser open in the Unreal Editor, you can select an asset and right-click on it to get a context menu. From that menu, you can get an asset path string written to the clipboard, which you can then paste into your C++ code, usually somewhere in a constructor for the specific class that's going to use it. Epic provide that functionality, but they don't really advise you use it. Firstly, it's really brittle. Get one of these asset paths typed incorrectly, or move the asset, or rename it in the content browser, and your C++ won't work anymore. At best, things just won't work properly in your game. At worst, welcome back to Crash City. Also, because of the way the CDO, that class default object thing, works, you may well end up loading that asset into memory before you actually want to use it, and keeping it there after you're actually finished with it, which probably isn't what you wanted. So, okay, if you're not really supposed to have these hard-coded asset references in C++, what are you supposed to do then? Well, one way is to define classes in C++ which have the appropriate type of properties for the assets they will use, but which don't actually specify a value for those assets. Then, in the Unreal Editor, you create blueprint classes which inherit from the C++ class, and they do specify values for those properties. Let's take a closer look at that. When you make a blueprint class that inherits from a C++ class, you can easily then assign assets to specific properties in it using the editor, and your C++ code can work with those things at runtime without actually ever having needed to know specifically what each asset was set to when the code was compiled. After all, the C++ code only needs to know that something is a texture or a sound effect or a material. The contents of the asset at runtime are almost irrelevant as far as the code is concerned. If you create your C++ classes which use assets in this way, not only does it protect you from broken, bad, or changed asset paths and the problem with constructors loading assets which hog memory, but it actually makes development much nicer. Firstly, the programmer of C++ classes isn't bothered about exactly which sound file or mesh or texture is going to be used at runtime, and so they can just concentrate on writing their code. And then, when using the editor, a level designer, for example, can easily use a blueprint derived from the class the C++ coder made and switch between different materials or sound effects without needing to have the code recompiled. And yeah, sometimes with indie development, that C++ coder and the level designer are the same person, but these benefits still apply. I frequently use this technique, opening the editor and easily swapping out placeholder meshes that I used for testing to actual game assets once I have them, and I can then easily swap them again if I want something else. And I was able to test that things worked with simple meshes like cubes or boxes instead of actual game assets, and know that the code worked without needing to stop doing useful work and go build a complicated mesh before I actually needed it. The problem is that there is a certain misconception that blueprints are somehow not for real programmers, and this is reinforced somewhat by the realization as a blueprinter that you eventually can't do everything you might want to do with them, which is why eventually many blueprinters want to get some C++ under their belts. The problem though is that that assumption is wrong. Blueprints are pretty much fundamental to Unreal development and should work hand in hand with C++. In general, blueprints are concerned with stuff relating to assets or layout or configuration, visual options, or possibly data, which can also be considered a type of asset. And there are certainly specific assets that wrap data, such as data tables. And then there is C++ for pretty much everything else to do with the logic of your project. I wouldn't want to code huge masses of nested branching, recursive, whatever type of logic with a blueprint. They just don't lend themselves to it, honestly. But they're perfectly valid places to hook up specific assets to properties or provide a simple response to an event. Similarly, C++ classes ideally shouldn't be overly concerned with the specifics of assets. Logic is their domain. For example, you might have a class for a first-person character with a camera. In blueprints, it'll be quite easy to set the camera up to the correct position that you need because you get instant visual feedback and you can keep changing it. In C++, you'll be working purely with numbers, and if you don't know what the correct height is to type in initially, you'll be doing it by trial and error and needing to recompile code constantly. It also won't give you the ability to quickly change it should your needs change during development. Code modules. You can think of Unreal modules as distinct blocks containing code. If well designed, those blocks will generally contain code related to specifically one or possibly more areas of functionality that can stand on their own. Your Unreal C++ project automatically has its own module called the primary module, but you can choose to add other modules. So why would you do that? Well, you don't have to, of course, but deciding to separate your game code into distinct modules has several advantages. Firstly, it makes you think about things in a more, modular way. You need to consider what are the specific parts of your game and how they can be implemented as distinct units of work with their own sets of responsibilities. Another good reason to implement your code within modules is that each module is compiled separately. As your project grows larger, it often takes longer to compile. But if you separate the code into different modules, only the modules that have changed need to be recompiled. And for larger projects, this can save you an awful lot of time. If you have modules that you're not actually using, they will automatically be excluded from the compilation. That sounds a bit silly at first because you're not daft enough to go to all the trouble to have modules in your code that you don't intend to use, right? But it's actually quite common because you can have modules in your project which contain code that is only used by the Unreal editor, for example. So when you compile your project for a shipping build, that code is not needed. You can also control which modules are used based on the specific platforms that you're compiling for, and you have control over when the modules are loaded and unloaded at runtime. Plugins. Plugins are Unreal's way of having stuff in a container, the plugin, which can be added to projects. I use the word stuff then because plugins can consist of pretty much everything you use in Unreal games. They can contain their own asset content, such as textures, sound effects, animations, and meshes. They can also contain code in the form of one or more modules. They don't have to include content, and they don't have to include code. You can have code-only plugins, and you can have plugins which only provide assets, or a mixture of both. It's your choice. You get the benefits listed for modules, plus you can have associated assets, and all wrapped up in a package designed to be reused, distributed, and even sold independently of one specific project. If you plan to produce multiple games, plugins can be a way to develop and test functionality or assets once, and then reuse them all over the place. For example, you could have an assets-only plugin where you have your master materials, some commonly used material instances, and associated textures. Then each project that uses it can create specific material instances instances based on those master materials, and you don't need to worry about migrating a bunch of individual material and texture files around. You could build a plugin with all the code required to perform your custom save and load game functions, and it could include C++ base classes that define user widgets for the user interface to manage those saved games, with descriptions and thumbnail support. Further than that, you could have actual user widget assets derived from those C++ base classes that give the using project a default set of actual widgets to use. Going even further, you might design several themes, a modern one, a sci-fi one, and an oldie worldy one, each including specifically styled widgets derived from your C++ base classes. You could then use that plugin with any game that needs save load functions, and you have default and theme widgets right out of the box, plus the ability to make new themed widgets for each specific project if you choose to do that instead. Unreal Framework classes. There are a whole truckload of classes provided by the Unreal Engine. Some are frequently used, and you will get used to them pretty quickly. Others you might only encounter in unusual or specific situations. UObject. All the Unreal classes derive from a class called UObject. For many of your own classes, which will encapsulate specific game data and functionality, you will inherit your class directly from UObject. Bear in mind, all classes you make which derive from UObject and any of its descendants, other than a actor, will be named starting with an uppercase U. For example, UMyObject. You don't have a choice about that. Various parts of Unreal rely on that naming convention, so just try to accept it and move on. A actor. Probably the next most frequently encountered class is A actor. Classes which derive from A actor represent anything which can be placed in your game world and have a location. This includes things the player can see, such as static meshes and even enemies, and also things they can't, such as collision triggers. Just as with UObject, classes which inherit from A actor or a descendant of it must be named with an initial capital A, such as A myActor. Again, don't try to fight it, just take a deep breath and accept that that's how the Unreal Engine works, so you gotta roll with it. This is not a problem if you're coming from a Blueprint background with no traditional coding experience, but existing programmers have invariably been indoctrinated into certain formatting conventions from whichever languages they've been using. These convention zealots battle about such things as whether a particular letter in a name should be upper or lowercase, and if it's allowable to use underscores. And don't even get them started on the go-to keyword. Unreal is how it is, and it's more than fair to say it's proven itself. Epic are letting you use it for free, so, there's that. But what about the classes which form an actual framework for your game? The first class I'm going to talk about is GameMode. There are actually two GameMode classes you can use when you want to create your own game mode. A GameMode and A GameMode base. Just to keep things simple, A GameMode is kept more for historical reasons, and these days, if you do want to make your own game mode, A GameMode base is the class you would derive from. In the Unreal documentation for GameMode, Epic state the main idea behind it is that it contains certain rules that pertain to your game. They go on to say that these rules are things like how many players and spectators are allowed, spawn locations and respawn behavior, if the game can be paused and how that pausing works, and how level transitions should be handled. The problem I have with that description though is that apart from the last one, everything else is still basically focused on making multiplayer shooter type games, and so it's not immediately clear why you'd want to make your own game mode class if that isn't the kind of game you're making. The game mode that you use defines a bunch of things: a default pawn class, the pawn in this case being the player's character, a HUD class which is used to display widgets on the screen, things like the player's health or money or notifications, a player controller class which handles the input from the player, a game state class responsible for communicating game related information between the various clients and server, a player state class which is responsible for communicating individual player information between the clients and the server, and finally a spectator class which, you guessed it, is yet another multiplayer Unreal Tournament type thing with quite a limited scope for the vast majority of games. So having said all of that, the first thing I would probably say is don't even bother making your own game mode subclass in C++. Why not? Well, because it doesn't really do anything useful for you. If you create a blueprint from game mode base, you can then easily set and change all those things I just talked about, however you like, right inside the editor. But if you do the same thing in C++, you can't change those things in the editor, meaning you're back to having to edit C++ code and recompile it if you want to make make alterations, which honestly kinda sucks. Now, my previous explanation of what the game mode class is for, based on the Unreal documentation, may have left you, as it did me, quite frankly underwhelmed. Let me just say though that for the vast majority of games, you can create a single blueprint game mode, set up those defaults, and just use it for the entire game. However, where it does become useful is games where you might have different environments or even mini games. For example, when the player in your RPG game is rampaging through the countryside, slaying ferocious beasts and looting mysterious treasure chests, you could use a game mode where you have defined a character pawn with armor and a sword, and a HUD that automatically displays the character's health and magic, and knows how to do notifications of XP and gold after creatures are slain, using various combat actions and spells which are initiated from a player controller. But then, when the player transitions to the inside of a tavern, you've decided that your game will switch to a more social setting. The player's pawn is changed to one that's no longer wearing its armor or brandishing its sword. The player controller no longer has combat moves, but understands actions for walking around the tavern and talking to people, as well as a different HUD, which no longer needs to show health, but instead displays things such as the player's social status and the amount of gold they can wage on tavern games, and possibly how drunk they are. So even though you might not want to write your own game modes in C++, let's take a look at the classes that you can set with one, as those are interesting and useful to create. Default pawn class. A pawn represents something in the world that can be controlled, either by the player or by AI. In essence, it could be anything. A person, a robot, a car, a bouncing ball, or a sentient washing machine. Usually the class will determine what the pawn will look like and how it may behave and move in the world. A character is a type of a pawn that has been created to represent roughly humanoid, bipedal type characters. A character comes with loads of extra stuff to support that role. For example, it's set up to use a skeletal mesh, which the basic A-pawn class it derives from is not. In addition to the mesh, the A character has an upright capsule component used for detecting collisions, and a character movement component which simplifies allowing a character to walk, run, fly, fall, and swim, and allows you to control the speeds at which they can do these things. You can set how the character is affected by gravity, how well they float in liquids, and how they affect physics interactions. The HUD class. Using A HUD classes is somewhat optional, because you do not need to use one to display UI widgets on the screen, but they are a good way of doing so, allowing you to set up various widgets and provide additional logic to display, hide, and update them as required during play. The player controller class. A controller is something which controls a pawn. Sometimes that's a human player, and sometimes it's game AI. For a player controller, it's obviously a player that is doing the controlling. A controller possesses the pawn that it's going to control. Your controller may listen for various input events, actions, and directly do something with the pawn it is controlling, such as making it walk forward, begin to jump, or fire its gun. For simple games, some developers prefer to bypass this class, specifying the default player controller class in their game mode and listening for these events directly inside their A pawn or A character. I understand the appeal of this to new developers. It feels like one less class to deal with, but honestly, it's not so bad, and if you use them, I think the result is much cleaner, more orderly code. Game state. The job of the game state class is to know about general game information and notify each individual client about it in a client-server situation. It's suited for things like how many players are in a match, how much time is remaining in a game, the different team scores, that kind of thing. You can safely ignore this class if you're not interested in making a multiplayer game. Player state. Each player state is concerned with the details of a particular player. It might have things like their name, their current score, etc. The player state is responsible for updating all the clients in a similar way that the game state is. You can also safely ignore this class if you're not making a multiplayer game. Spectator class. This is, once again, a multiplayer tournament type thing. It's used to specify a class which usually represents a dead player who can fly around the world looking at a match they were in before they were killed and waiting to respawn. You can, again, safely ignore this class if you're not making a multiplayer game. U-Game Instance. Each game has a single instance derived from the U-Game Instance class. There is only one instance of a game instance class for your game when it runs. This is what some programmers refer to as a singleton. When your game starts, that instance is created and it lasts until the game shuts down, regardless of if the player changes levels, their character dies, or if they go back to your main menu screen, it's still the same instance. So it's a good place to have code and data which you want to exist for the entire execution of your game. And that is what Unreal programmers generally used to do. They created their own class inheriting from U-Game Instance. But then Epic came up with something better, subsystems. Epic realized there are parts of the engine which operate in a similar way, and rather than the program programmer needing to make their own game instance class, which could quickly become very bloated and tightly tied to a specific project as more and more bits were added to it, they made subsystem-based classes for certain parts of the framework. So in a nutshell, what you do with subsystems is you make a class inheriting from a specific subsystem class, and Unreal then automatically sees these and creates the instances for you when it runs. Neat, huh? This means that rather than a brittle, bloated U-game instance class, which will generally be integrated very tightly to one project, you can now make several much more elegant U-game instance subsystem classes, one for each distinct concept you want to encapsulate. Want to wrap up code which initializes and manages your save game system? That could go in a game instance subsystem. Want to track achievements in a single player game, distinct from which save game or playthrough the player is using? That might also be another game instance subsystem. Each one can be its own independent class, which makes them more likely to be reusable in other projects. And yes, you absolutely can put them in plugins too. And the great thing is, there's no complicated configuration needed to use them. When Unreal fires up, it detects you have them and it initializes each one for you. And that initialization can even do some logic which you provide to decide if that specific game instance subsystem should even run at all. Tidy. Phew, well, we covered quite a lot there. Please don't expect you need to remember all of that. The main point was just to give you a bit of background. You can always come back and replay parts of the video that focus on things you need when you need it. And check out some of the links in the video description to the official Epic Unreal documentation. In the next video, we'll tackle some practical examples with some actual project code for you to follow along with. I hope you can join me for that. Until then, good luck with all your endeavours.